Alright, ladies and gentlemen, what we're again asked to do here is to draw a graph, but not to use the calculator. Let's use what we know Euler's function looks like. So, if you recall, Euler's function looked like this, and this was a horizontal asymptote. And of course that would be the line y equals 0. Y equals is always a horizontal line, so the x-axis has that equation. And of course this has arrows on both ends because this graph does not stop. Remember what it means to be an asymptote. It gets closer to this line, but it never touches it. Now, from the past, what you learned is when you take a function and put a minus in front of it, what you're really doing is you're multiplying the y value by -1. And if you recall from the past, what that does is that reflects the graph with respect to the x-axis. So, the asymptote doesn't change. We still have the line y equals 0 as my asymptote. But here's what does change. This graph now is reflected with respect to the x-axis. So for example, instead of this being the ordered pair 0, 1, it will be 0, -1. This portion will look like this, and this portion will look like this. So we've done a perfect reflection with respect to the x-axis. If I drew the original curve, it would be up here, and the line y equals 0, which is the x-axis, would look symmetric since we did a reflection. The domain here, when I scan from left to right, is still all real numbers. The range here, however, coming from bottom to top, we would be coming from the direction of -infinity, and y is 0, but we put a paren on it since we don't reach it. So the important thing to remember here is when you see the minus in front of e of x, that was like what you did in the past. If you had a function and you wanted to graph the opposite of that function, you reflected it with respect to the x-axis. Now, this time, the negative is in front of x. So what we're doing basically is we're crossing over the y-axis. So we take our original picture, okay? We take our original picture, which looks like this roughly, okay? And I'll put asymptotes on in a minute. If x is basically, if we are doing this, okay? If we had an original function and now we want to graph this, if the x value has been multiplied by -1, what you're doing is, if I had an x point here, if I had an ordered pair here, and I multiplied x by -1, the new ordered pair would be here. So we're crossing over the y-axis. So what ends up happening, if I do a reflection with respect to the y-axis, this little portion comes over here, and this portion comes over here, so we end up getting a graph that looks like this. That is called a reflection with respect to the y-axis. The asymptote is still the same. That would namely be the line y equals 0. The domain here, if we scan from left to right, we'd be going from negative to positive infinity, so all reals. And the range here again would be going from 0 to infinity, but of course not including 0, since our graph doesn't touch the line y equals 0, it's asymptotic to it. Okay, please show asymptotes. We did, and in this case those asymptotes are affecting the range. All right.